Hello friends, welcome to this practical course on ETABS. In this lecture, we will be modeling staircase in ETABS and we'll be also calculating the staircase loads and apply it in our ETABS model. So first of all, as you can see from the architectural plan, in this area, we'll be modeling our staircase between these four columns. So in ETABS, if you see, in this area, we are going to model our staircase. That is between grids C and D and grids 4 and 5. First of all, in the plan view, we will be modeling the staircase connecting story 1 and story 2. So go to story 1 by clicking on this arrow, that is at elevation z is equal to 1.5 meters. First of all, we need to create reference points in order to model the landing slabs. In order to create the reference points, select this beam, go to edit menu, click on edit frames and click on divide frames option. We are going to divide this beam into two equal parts. Click on apply and click on OK. So now you can see that ETABS has divided this beam into two equal parts. Now select these two joints, go to edit menu, click on replicate. We are going to replicate these 2 points in the y direction by 1 meter, since the width of our landing slab is 1 meter. So type 1 here, click on apply and click on OK. So now you can see that we have our reference point so that we can model our landing slab at the level of story 1. So we will go to this draw floor plan button in order to model our landing slab. The thickness of the slab will be 150 mm, which is similar to a typical slab. So select slab 150 from the list and click on these 4 corners of the slab in order to model our slab. So here you can see that we have modeled our landing slab at story 1. Since we have divided this beam into two equal parts, however, if you see in reality this beam will be continuous beam. So select these two beam and let's rejoin this beam again. So go to edit menu, click on edit frames and click on join frames option. So now you can see that this beam is again rejoined. Now we need to also model mid landing slab at the mid landing level. So what will be the elevation of this mid landing slab? As you know that floor to floor height is 3.35 meters. So the elevation of this mid landing slab will be half of this 3.35 meters. So if you see here, from base to story 1, the height is 1.5 meters and we are starting our staircase from this story 1. So we will have mid landing slab between story 1 and 2, somewhere around this level, which will be half of 2.75 meters. So the elevation of our reference plane will be 1.5 meters plus 2.75 divided by 2, which will be 2.875 meters. So in order to create the mid landing slab, we need to add the reference plane in ETABS. So let's add the reference plane. So go to edit menu and click on edit stories and grid system option. Click on modify show grid system and select reference planes. Click on add. So we are going to add the reference plane at 2.875 meters. Click on OK and again click on OK. click on refresh view and again click on OK. So now if you see, between story 1 and 2 we are having a reference plane at 2.875 meters. Now let's divide this beam again in order to create the reference points. So select this beam, go to edit, select edit frames and click on divide frames option, click on apply and click on OK. Now select these three joints. This time we will be replicating these three joints in minus y direction. So type here -1 in the dy direction. Click on apply and click on OK. Now let's draw the mid landing slab. So select draw floor plan button. The property will be slab 150 and click on these four corners to draw the mid landing slab. Rejoin these two beams again to have a single beam. Now we'll also need to create a landing slab at the level of story 2. So go to story 2. We will follow the similar procedure that we did for creating the landing slab at story 1. So select this beam, go to edit menu, click on edit frames and divide this beam into two equal parts. Now select these 2 points, go to edit, then click on replicate and replicate these two joints at a distance of 1 meter. Click on apply and click on OK. Now let's model the landing slab at the level of story 2. So click on draw floor plan button and click on the 4 joints to model the landing slab. Now again rejoin this beam, since in reality this beam will be a single beam. So we have created the landing slabs and the mid landing slabs. Now we will connect these all slabs with the help of inclined slabs. So go to story 1, click on this draw floor plan button, click on these points. Now the other 2 points of the inclined slab will be at the mid landing level. So with this tool active, click on this up arrow to move upwards at the level of reference plane and then click on these 2 points. The starting point will be again at the level of story 1. So again with this tool active, move downwards and click on this point to complete the inclined slab. Here you can see in 3D that a inclined slab is modeled. We will follow a similar procedure to model the inclined slab between reference plane and story 2. So go to the reference plane level, click on draw floor plan button, click on this point, then click on this point, then move up at the level of story 2, then click on this point, and again move downwards to complete the inclined slab. So here you can see in 3D the inclined slab has been modeled. Now let's model the staircase between story 2 and story 3. In order to model the staircase between story 2 and 3, first of all, we need to add a reference plane between story 2 and story 3 in order to model our mid-landing slab. And the elevation of that reference plane will be 1.5 meters plus 2.75 meters plus half of 3.35 meters. So that will be equal to 5.925 meters. So we will add a reference plane at an elevation of 5.925 meters. So open eTabs, go to edit menu, select edit stories and grid system option, click on modify show grid system option, click on reference planes, click on add and enter the value as 5.925 meters. Click on OK, click on refresh view and again click on OK. So now you can see that we have a reference plane between story 2 and story 3. Now again we need to have a landing slab at story 2, then we need to have a mid landing slab at reference plane 2, and then again we need to have a landing slab at story 3. So now this time what we will do is we'll replicate the landing slab from story 1 to story 2. So select this landing slab, go to edit menu, go to replicate, and in the story option we'll replicate this to story 2. So select story 2, click on apply and click on OK. So now you can see that you have a landing slab at story 2. Now the landing slab that we created at story 2 we'll replicate it to story 3. So select this landing slab at story 2, again go to edit menu, select replicate, and in the story option we'll replicate it to story 3. Click on apply and click on OK. Along with that, we also need to replicate these joints. So select all these 3 joints, again go to edit menu, replicate, and replicate it to story 3. We also need to replicate the 3 joints that we created at level of story 1 to story 2. Now we'll create the mid landing slab at story 2 at reference plane 2. So first of all we need to add beam. So click on this draw beam option. Beam will be B2 300 by 450. Draw a beam between grid C and D. Then divide this beam into 2 equal parts. Copy these 3 joints and we'll replicate it at a distance of -1 in the y direction. Now first of all we need to create inclined slab between story 2 and reference plane 2. So select this draw floor plan option. The property will be slab 150. Click on this joint, then click on this joint. Then keeping this tool active, go to the level of reference plane 2. Click on this joint, click on this joint, and again go downwards and click back on this starting point. So you can see that the inclined slab has been modeled. Okay. We also need to create the mid landing slab at story 2. So click on this draw floor plan option and click on the 4 corners. Oops, I have. So click on this draw floor plan option and click on the four corners to draw the mid landing slab. Now we need to also create an inclined slab connecting reference plane 2 and story 2. Sorry, reference plane 2 and story 3. So go to the level of reference plane 2. Again, select draw floor plan option. Click on this point. Click on this point. Then keeping this tool active, go upwards at the level of story 3. Click on this joint. Click on this joint. Then again go downwards and click on this starting point to model our inclined slab. So now you can see in 3D that our inclined slabs have been modeled between story 2 and story 3. Now, first of all, what we will do is we will replicate all our landing slabs and mid landing slabs from story 2 and story 3 to the upper stories. So first of all, go to the level of story 2. So this will be your landing slab. So select this slab, then go upwards. Select this mid landing slab at the level of reference plane 2, and again go upwards, and then select this landing slab at the level of story 3. Now go to edit menu, go to replicate, and we will replicate it from story 4 to 9. Hit apply and click on OK. So now you can see that it has replicated it to the upper levels. Now we'll also replicate these inclined slabs to upper levels. In order to replicate these inclined slabs to upper levels, first of all we need to hide these slabs in order to select these slabs properly, inclined slabs. So what we will do is, first of all we'll go to, first of all activating the 3D view, go to select menu, then go to select, and then click on object type. Click on floors, click on select, and click on close. Now in the 3D view, right click anywhere in the wide screen and then click on hide selected objects. So this will hide all the slabs except these inclined slabs. Now select these inclined slabs from the 3D view. Now go to edit menu, then click on replicate option, and then in the story option we are replicating the inclined slabs from story 2 to 3 to all the above stories. So that will be from story 4 to story 9. Click on apply and click on OK. So here you can see that all the inclined slabs have been replicated. Now again right click anywhere in the wide screen and click on show all objects. So this is how we'll model our staircase in our G+7 floors residential building. Now I will show you how to calculate the staircase loads and apply it in our ETABS model. The first load that we need to add on our staircase will be the dead load on landing slabs. So the dead load on landing slabs will include mortar plus clay tiles plus ceiling plaster. So you can add a value of 0.52 kN per meter square on the landing slabs. The next load that we need to add will be the live load on staircase. So as per IS 875 part 2, the live load on staircase will be 3 kN per meter square. And the third load that we are going to add will be the dead load of the steps on the inclined slab. So as per the calculation this came out to be 2.5 kilonewton per meter square. So I have prepared an Excel spreadsheet, and I will show that spreadsheet, and I will show how this calculation of the steps is done. So as you know that the steps will be resting on this inclined slab. So this is our step. So the step will have a tread and a riser. So this step will be imparting the superimposed dead load on the inclined slab, and we need to also add this dead load of these steps. So let me show you how to calculate these dead loads. First of all, I have taken the value of tread as 300 mm and the value of riser as 180 mm, which is equal to around 7 inches. And the floor to floor height in our building is 3350 mm. Now, first of all, we will calculate the total number of steps required up to the mid landing level. That is, total number of steps in one flight. So, to calculate the total number of steps, what we need the height up to the mid landing level. So that will be half of this 3350, and we know the value of riser of each step, that is equal to 180 mm. So if I divide half of 3350 by 180 mm, I will get the total number of steps. So what I have done here, first of all, I have taken the half of 3350 and I am dividing it by the value of height of one riser, which is 180 mm. So I will get the total number of steps required. So that is 10 steps. Now I will calculate the area of step. So we know that area of triangle is equal to half into base into height. Correct? This step is in the shape of triangle. So to calculate the area of this step, it will be equal to half into base, which is nothing but the value of tread, and into height, which is nothing but the value of riser. So this will give me the area of step. And once we get the area of step, we will multiply it by the length of step. So this will be the length of step. So multiplying the area by the length of step, I will get the volume of step. So what I have done, I have calculated the area, that is nothing but tread into riser, and I am multiplying this value by 10 to the power minus 6 to convert from mm square to meter square. Once I get the area, I will multiply this by the length of step. Now what is the length of step? As per our architectural plan, the length of step will be this much. That will be, we know that the staircase area is 8 feet by 16 feet. So the length of step will be almost half of this 8 feet. You can calculate exactly the length of step from this AutoCAD file. So in our case, the length of step is 1.38 meters. So multiplying the length by area, we will get the volume of each step. And we know that unit weight of brick is 19 kilonewton per meter cube. So I will multiply unit weight by volume. I will get the weight of each step, and total weight of all the 10 steps will be equal to weight of one step multiplied by 10. So this will give us 7.07 kilonewton. Now I will find the area of inclined slab from ETABS. Now I will switch back to ETABS. If you select any slab, and if you select any inclined slab and right click on that, then you will get the area of that inclined slab. So that is 2.89 in our case. So we'll enter the value here as 2.89. Now I want the area load. So what I will do, I have total weight of all the steps. I will divide it by the area of that inclined step. So I will get the load on the inclined step, which is nothing but 2.89, which is nothing but 7.07 divided by 2.89. So I will get the load on inclined step as 2.5 kilonewton per meter square. So now I have all the values. So I will apply all these load values in ETABS. First of all, I will apply a value of 0.52 to all the landing slabs. So from the plan, first of all, make sure that here all story option is selected. Then select all these landing slabs. Go upwards, select mid landing slab as well. Again go upwards, select this, and go to the topmost floor and check that all the landing as well as mid landing slabs are selected. Now I will go to assign, I will go to shell loads, then I will click on uniform. So we are applying dead load of 0.52 kN per meter square, and the direction will be gravity. Click on apply and click on OK. The next load that we are going to add will be the live load on staircase. So live load on staircase, we will add it in both the incline slabs as well as the landing slabs. So first of all, let's add the live load in the landing slabs. So go to select option and click on get previous selection. So all the landing slabs have been selected, which we had selected previously. Now again go to assign, go to shell loads, go to uniform. This time we will select the load pattern as live. The load value is 3 kN per meter square. The direction will be gravity. Click on apply and click on OK. The same value of 3 we need to also assign it to the inclined slabs as well. So in the 3D view, right click anywhere. First of all, in 3D view, we need to hide all the slabs. So go to select, in the object type, click on floors, click on select, then click on close, then right click anywhere in the 3D view and click on hide selected objects. Now you can select all the inclined slabs by left clicking on it. And again we'll go to assign, we'll go to shell loads, then click on uniform, and we'll apply a value of 3 in the live load. Click on apply and click on OK. The next load that we'll be adding will be the load of the steps. So go to select and click on get previous selection. So again all the inclined steps have been selected. So we'll go to assign, we'll go to shell loads, we'll click on uniform. The load pattern will be dead since it is the dead load of steps, and the value is 2.5 kN per meter square. The direction will be gravity. Click on apply and click on OK. Now let's design the staircase. In order to design this staircase, we are going to use the standard design table that is given by Super Civil CD software. So first of all, based on the architectural plan, we know that length of our landing slab is 3 feet. Then length of our inclined slab is approximately 12 feet 6 inches, and length of our mid landing slab is 3 feet. So the total span, that is nothing but length of each flight, is equal to 3 feet, that is nothing but the length of landing slab, plus 12 feet 6 inches, which is nothing but the length of inclined slab, and again 3 feet, which is nothing but length of mid landing slab. So total span is 18 feet 6 inches, which is approximately 5.6 meters. So if you look into this design table, so for a span of 5.6 meters, we can provide 16 mm dia at 140 mm center to center main steel and 8 mm dia at 200 mm center to center distribution steel. And the permissible cantilever that is allowed for this span will be 1.35 meters. So in our case, the cantilever provided is 1 meter. There is nothing but the length of the mid landing slab. Since this cantilever length is less than 1.35 meters, so it is okay. Now you might be wondering that why we are modeling this staircase in ETABS, since we are directly giving the reinforcement values from this table. The reason is that after modeling the staircase and applying the loads on it, the 4 columns on which the staircase is supported will be experiencing maximum bending moment and shear force. And if we do not model the staircase, then those 4 columns will be under designed. So this is the reason why we are modeling the staircase in ETABS. So guys, that's all for this video. If you like this video, then please subscribe to my channel and also press the bell icon so you don't miss any future update. Thanks for watching. Bye for now.